All right, so now we're going to talk about ionic bonding. It's not simple ionic bonding, but it's called advanced ionic bonding quest. And we're going to deal with something called polyatomic ions. So polyatomic means many atoms. A polyatomic ion, therefore, is an ion that is made of more than one atom. An example of a polyatomic ion is sulfate, which is SO4 and has a charge of 2 negative. So sulfate is composed of 1 sulfur and 4 oxygen atoms, and the overall sulfate has a negative 2 charge. Here are 9 polyatomic ions that you need to know. Either write them on your periodic table or memorize them. Sulfate, SO4, 2 negative. Cyanide, Cn, negative 1 charge. Acetate, C2H3O2, negative 1 charge. Phosphate, 1P O4, 3 negative charge. Ammonium, which is the only positive one that we have that you have to know, which is NH4, positive 1 charge. Hydroxide, which is OH, negative 1 charge. Nitrate, NO3, negative 1 charge. Chlorate, ClO3, negative 1 charge. And carbonate, CO3, 2 negative. So a couple questions here to consider, all right? The first is, what do all polyatomics with 8 have in common? Let's look. Sulfate, acetate, phosphate, nitrate, chlorate, carbonate. Well, all eights have an oxygen, right? Which two atoms do you think compose the polyatomic ion called silicate? Well, 8's oxygen, sila. I look at the periodic table and I look right over here, silicon. So I'm going to say silicon because of the sila, and oxygen because of the 8. So what's the difference between calcium nitride and calcium nitrate? Well, calcium nitride is Ca and N, right? It's calcium and nitrogen. Calcium nitrate is Ca and nitrate, which you look up here, is NO3, okay? So the difference is that one is monatomic, right? Simple. And the other has a polyatomic ion, so the 8. So nitride, nitrate, two entirely different things. Have to learn those. So writing formulas of polyatomic ions. So first of all, you must remember that you can never change the formula of a polyatomic ion. Sulfate is always SO4 negative 2. It's never some derivative of it like S2O8 4 negative, right? You don't double everything or anything else. So here's some examples of chemical formulas that contain polyatomic ions. Ammonium chloride is formed when 1 ammonium, NH4 positive, and 1 chloride ion make a formula. So 1 positive, 1 negative, it's a 1-to-1 ratio. It's just NH4, Cl, ammonium and chloride. Sodium sulfate requires 2 sodium ions because sulfate has a negative 2 charge, right? So negative 2, positive 1. So we need to have 2 positives to balance the 2 negatives. So we have 2 sodiums and 1 sulfate. So that's Na with a 2 because there's 2 sodiums, and then SO4 is just there. So sodium sulfate, all right? Calcium hydroxide. Calcium has a positive 2 charge. We know that because calcium's right here, right? It's a group 2A. And hydroxide is OH with a negative 1 charge. So we need 2 hydroxide ions to combine with the 1 calcium ion. So the overall charge is 0. So calcium hydroxide is written like this. So look carefully. When we have a polyatomic ion in a formula and there's more than one, we put parentheses around it, and then we put the 2. So polyatomic ions, when there's more than one, need parentheses. So here are some more examples. Potassium acetate, K, C2H3O2, it's a 1-to-1 ratio. Magnesium nitrate, magnesium's positive 2, nitrate's negative 1. So we need 2 nitrates for the single magnesium. So it's Mg with NO3 in parentheses with a 2. Barium phosphate, barium's positive 2, phosphate is negative 3. So we need 3 bariums and 2 phosphates to get it to balance out. Ba3PO4 is in parentheses because we have 2. Calcium carbonate, calcium is +2. Carbonate is -2. Right? Calcium's +2 because it's 2A. So it's a 1-to-1 ratio. So now it's CaCO3. So those are some different formulas with that. We just bounce the charges. The only thing that's different is that if we have more than one polyatomic ion, we must put the polyatomic ion in parentheses and put the subscript. All right. So calcium hydroxide is written as with the parentheses with the 2. Why can't it be written like CaO2H2? Right. Without the parentheses, 2 means we have 2 OHs. Putting a 2 like this means we have 2 H's and 1 O. So the parentheses means that we have 2 OHs instead of just 2 H's. So the parentheses means that we have 2 OH instead of OH2, which means one O and 2 H. Okay, so barium phosphate is Ba3PO42. Why can't it be written like this? Well, because with the 2 in parentheses, we have 2 PO4s. But when we write PO42, that means we have 1 P and 42 O's. So it's different, right? So let's name each of the following compounds, and they each include 1 polyatomic ion, and then we'll have you practice writing some formulas and see if you can do that, all right? So go ahead and do the naming and do the formulas, and then I will get on the board and do the rest with you. Do not worry about the acids. We'll talk about acids on a different day. All right, number 6, name the following compounds. Each includes at least 1 polyatomic ion. So as we name these, right, I'll walk you through and hopefully I'll spell them correctly. But I look here, I got Na, which is sodium, and PO4, which is phosphate. So it's as simply as saying sodium, first misspelling, sodium phosphate. So you don't have to worry about anything but just the names of the 2 ions. So we got NH4 and SO4. NH4 is ammonium, and SO4 is sulfate. So there's the name. And C, I got Mg, and then I got C2H3O2. Again, any of these polyatomics are way up here at the top, right? So the names are right here. So C2H3O2 is acetate. There's sulfate and phosphate that we did earlier. So I know that C, first name, magnesium, last name, acetate. NH4 and S. NH4 is ammonium, and S is just sulfur. So ammonium. But remember, sulfur is not just sulfur. If it's the anion, it's an ion. It is sulfide. So CaCO3. Ca is calcium. CO3 is right here. Carbonate. So it's calcium carbonate. And then our last one, Ba is barium. And then NO3 is right here. It's nitrate. So barium nitrate. It's not all in one, all near up. It's barium nitrate. That's all one, or 2 words. All right. So just take the first element or polyatomic, write the name. The second one, if it's polyatomic, just write the name. But if it's not polyatomic, if it's one of our monatomics, remember we have to end them in IDE. Okay? And that's the names for this one. All right. So we want to write this number 7. on the Advanced Ionic Bonding page, we want to write formulas for the following ionic compounds, and they all contain polyatomic. So, A, lithium phosphate. So here's what I do: is I look at lithium, which I know is Li, and phosphate, which is PO4 3 negative, and that's from the list at the top of the sheet. So lithium, I look at the periodic table. Lithium's group 1, so it has a positive 1 charge. And now I just balance my charges. I have -3, +1, so I need 3 more positives, so it's Li3 PO4. And that's the formula for lithium phosphate. B, ammonium oxide. So ammonium is one of our polyatomics. It is NH4, the +1 charge. Oxygen is oxide, it's just O. And I look in the periodic table, oxygen is group 6A, which is a -2 charge. So it's 2 negative. +1, -2, I need 1 more positive to get things to balance. 2 of these, 1 of these charges are balanced. Now, since it's polyatomic and there's more than 1, I must use parentheses and then put my O. Okay, so this is ammonium oxide. C, barium hydroxide. So barium hydroxide is Ba. Hydroxide is different. Oxide, this is oxide. Hydroxide is OH, and it's polyatomic. So oxide, monatomic. Hydroxide, polyatomic. Okay, and it's a -1 charge. Barium, I look at the periodic table. +2, it's in group 2. Boom. +2, 1 negative, add another negative, 2 negatives, 2 positives. I have 1 Ba. I have 2 OHs. Now again, parentheses if I have more than 1 polyatomic ion. So it's BaOH2. So that's A, B, and C on the sheet. Now we're going to do D, C, or D, E, and F. Hopefully you got all these. I guess if not, you can rewind and pause, right? So let's look at letter D, calcium cyanide. Calcium is Ca. Cyanide's polyatomic, big C, big N, the negative charge. Calcium's group 2A metal, +2 charge. +2, -1. Add another negative to balance my charges. So I have 1 of these, 2 of these. Ca, and since cyanide is a polyatomic, I put parentheses around it and put a 2. Calcium cyanide. Sodium chlorate, all right? Chlorate. So chlorate is ClO3, -1 charge. That's an L, ClO3. And then sodium is Na. When I look at the periodic table, sodium is on the group 1. It's alkali metal, which means it's a +1 charge. Positive, 1-to-1 ratio, NaClO3. Sodium chlorate. And the last one, potassium sulfate. Potassium is K. Sulfate, polyatomic. SO4 2 negative. Potassium, I look, is a group 1 metal, right? So it's a +1 charge. I need 2 of these. K2, SO4, potassium sulfate. Number 8, the difference between calcium nitrite and calcium nitrate. I kind of talked about that, but let's write the formula for each of those. Calcium nitrite. Calcium is Ca, nitrite is just nitrogen. Again, I'll look at the periodic table. Calcium, we already know, is +2. Nitrite is group 5A. It's between carbon and oxygen, which means it's going to have a -3 charge. And we balance the charges, and it's one of those 3-2 ones, right? -6, +4, +6, -6, 3 of these, 2 of these, so it's Ca3 and 2, calcium nitrite. And then calcium nitrate. Calcium, again, Ca, 2 positive. Nitrate is NO3, -1. I need more negative charge. two negatives, one and two positives. Everything's balanced. 1 and then 2. CaNO3 with a 2 for calcium nitrate. So calcium nitride, calcium nitrate. Keep track of your names so you can write the formulas correctly.